Make sure to check in. The thing is, this helps us gauge how many people come to our events, and we also submit the number to AS, and they fund all our food. So if you want to keep having free food at all of our events, then make sure you always check into every single event you go to. Okay, I'll just go onto the content now. So today's agenda is basically, first of all, I'm just going to recap of what we learned in the previous workshop, so last Thursday. And then we're going to talk about functions, data structures, and classes in Python. So starting off from last week's workshop, if any of you watched the recording or if you came here last week, then you know that we covered data types, how to do input output, conditionals like if, else and stuff, and also loops like for loops and while loops. Okay, so more people are coming in. I'll just quickly just say the agenda again, but basically we're just gonna recap from last week, talk about functions, data structures, and classes. So for the recap, data types, there are ints, which are basically just regular numbers you can think of, right? So it could be negative numbers like -1, or it could be positive numbers like 10,000, whatever, extremely large numbers, and also small numbers as well. And they're always in the range from -2 to the 31 to 2 to the 31 -1. And that just kind of comes from the things with bytes and stuff, which you'll probably learn in like CSE 20 and stuff like that. And then we also have floats. Floats are basically decimal values, so like 0.5, or also in the negative direction, you can have -3.0 and stuff. Same range as the ints. The only difference is this is decimal, whereas int is just the integer number. Then we have strings, which are basically just a bunch of characters together that can represent any text. It can be some sentences or a word, such as like hello world, or just it can also be just numbers that are treated as strings. So it could be something like the numbers in an address or something, or something like 1, 2, 3, some address and stuff too. And then another type we have are booleans. Booleans are binary values that can either be true or false, or on and off, 1, 0. Sorry. Let's see. So yeah, you can write them as true or false. 1, 0. 1 is true and false is 0. And then we have operators, which we covered last week as well. So operators are basically, there are a bunch, 4 different types of assignment, comparison, arithmetic, and logical. So in the assignment operators, you have things like equals, plus equals, minus equals, and more. So some examples include x equals 3, which is basically assigning the variable x to the value 3. Or you can also do x minus equals 2, which is basically going to be whatever value x is, you're going to subtract that by whatever you have on the right side, in this case 2. And also we have comparison operators, which are basically like comparing 2 values on the left and the right to see if they're equal to each other. That would be equals. If you want to see that they're not equal to each other, then it'll be the exclamation mark equals, which is the exclamation represents not. And then you also have the basic greater than, less than, greater than or equal to, and less than or equal to. Then, so for example, if you did the string apple is not equal to banana, what do you think would be printed in the console when you do this? Anyone? You can just raise your hand. What do you think the answer would be, true or false over here? If you have apple does not equal banana, is that true or false? Just raise your hand. True. Yeah. Okay. Cool. Then we have arithmetic operators. So y equals 4 modulus 2. And this is just modulus basically. If anyone remembers, does anyone give a shot? What is y going to be equal? 0. Okay. Why?
Remainder of the parameter.
Yeah, exactly. So the modulus gives you the remainder. In this case, 4 divided by 2, you don't have any remainder, so you're gonna get 0 for y. Then we also have the logical operators, such as and, or not. So for example, right here, you have 9 is less than 10 and apple equals banana. So anyone want to give it a shot for this last one? So it's this one statement ended with the second statement. The first statement, you're using the comparison operators to check if those values are equal. And over here on the right side, you also have a comparison operator. So do those two individually. See what you get. What is the binary value get, true or false, on the left and right? And then if you add that together, what do you get? When you think you have the answer, just raise your hand. Anyone? Yes. Why? Yeah, exactly. So on the left side, you have but 9 is less than 10, which is true. But then apple does not equal the string banana, so that's false. You have a true and a false. That's going to give you false. The only way you can get true for the and statements is when both values are true. But if this was an or, it would be true because one of the values is true. Yes. But it's evaluated, like, what do you mean exactly?
In Java, like you said, if the first statement of an and is false, then exactly
If the first statement is false, it doesn't matter. Okay. So the first statement is actually true. And if the first statement is false, then it's gonna give you false. And also it's ANDed, so you don't even need to check. It's the same logic as in other programming languages. So because it's an and, if the first statement is already false, you know your whatever, even if the rest is true, you're gonna get false. So it's like the same concept as in Java or C++ as well. But yeah. Any other questions? Okay, cool. Then we also covered inputs and outputs. So for example, over here, if you just print the argument, then it's just gonna print out the argument that you have passed in before to the console. And then the second part is where we covered inputs. You inside the input, you would have some sort of statement or any argument you want to have. That's going to be printed to the console, and then it's going to wait for the user to type something in. Whatever the user types in is always read in as a string value. So if you wanted a user to type in some numeric value, then you'd have to use typecasting as well, because whatever the user, even if it's like a number 10, it's going to be treated as a string. So if you assigned, let's say, name equals input, what's your name? Inside the parentheses over here, you had in quotations, what is your name? Question mark. Then in the console, the user will have to type, will be asked, what's your name? And then there's just going to be the program is just going to wait for the user to type something in. And whatever the user types in, let's say they typed in the name Nick or something, right? Then the variable name is going to be stored as the string Nick. But if you ask for the age equals input, what's your age? Then and the user enters like 19. The variable age is going to be stored as the string 19 instead of the integer. So you'll have to typecast that, and the way you typecast that is basically int, and then in parentheses you put in the variable. So int age will turn the string 19 into an integer 19. So as I said over here, no, so let's say it was a string 1, then you put the string 1 inside int. That's going to parse the string 1 and turn it into an integer. So now you can use addition and operators that you would typically use on integers for that. And you can also turn floats into int. So the float 2.3 can also be turned into an int. The way that happens is basically just cuts out everything after the decimal. So whatever is the actual integer value is what your int will give you. So when you wanna take a guess on what int 2.6 will give you? Yes. Did you raise your hand? Yeah. Two, yeah. So it just calculates everything after the decimal, so you just get 2. And then int false will give you 0 because false is equated to 0. If you put true inside, it would give you a 1. Then other type castings include floats, strings, and booleans. They kind of work similarly. You just pass in whatever you want to typecast it to, basically. Any questions on any of these? And if at any point, if any of you have any questions, just raise your hand. Yeah. Okay, so we also covered loops. So we have 2 types, for loops and while loops. And so, for example, in the for loops, we have for index I in range 10, you want to print the index. So, and you want to take a guess on what that would do? What this for loop would do. Okay. What this for loop would do? Yes. Yeah, so basically you since you specify the range to be 10, you're gonna loop through. So you start off at 0, you're gonna print the index 0, and then you're gonna go to the next one, 1, print at 1, keep going until 10. Yeah. And then the other example is when you are given a list, you made a list of numbers 3, 4, 6, 0, and 2, and you want to loop through that list. And for each number in the list, you want to print that number. Works similarly, except this time you're just gonna loop through these indices. So there are gonna be 1, 2, 3, 4, 5 indices. So you're just gonna go ahead. So you have index 0 is gonna be 3. So you're gonna print 3. Then you're gonna print 4, then 6, then 0, and then 2. Any questions on for loops? Okay, cool. And then we have also while loops. So on the left, you have I equals 0. Then the while loop, while I is less than 10, you want to print I and then increment I by 1. So, and you want to take a guess on what it would print out? Yes. 0 to 9. Okay, why only 9? Yeah, exactly. So you start off with I equals 0. 0 is definitely less than 10. So you go inside the while loop and print I 0. So 0 is printed. Then you increment I by 1. So now you have 1. 1 is less than 10. So you print 1 and so on until you get 9. So 9 is still less than 10. So you print 9. But then you increment it by 1 again. So now your I is 10. But 10 is not less than 10. If there was an equal, less than or equal to, then it would go into the while loop. But since it's not equal to, it's false, you exit out of the while loop. Then on the right side, you have another while loop, I equals 0. And while I is less than 10, if I mod 2 equals 0, then print yes. And then outside of that statement, we have I plus equals 1. Anyone want to take a guess on what this would be printed? Anyone? You can also discuss with people at your table if you're unsure. The while loop on the right over here. What do you think? How do you think this while loop works? You can just walk me through it or just tell me what you think will be. Yes. Oh. I'm sorry, could you repeat that?
So like it goes through and then every number.
Yes, exactly. So basically you start at 0, right? So 0 is less than you enter. 0 mod 2 is 0. So you're gonna print yes. Then you're gonna increment I by 1. So now I is 1. 1 is less than 10. But and then you come go through the if, right? Like if 1 mod 2 equals 0, it does not. So you don't go enter that if statement, you just go on to the next line and increment I by 1 again. So it's just gonna end up printing all the even ones because you're only printing when you're modding by 2 equals 0, which is basically an even number. Any questions on while loops? Okay. So now we're gonna go into the meat of this workshop, which is functions. So starting off, what are functions? Functions are basically code that can be called and used at any time. So for example, if you had the function greet, which printed hello world, then and if you called it, right, then it's just gonna print hello world to the console. You can call it anywhere in the code, as long and you can call it multiple times, as many times as you need or wherever you need. It just keeps everything concise. You don't have to keep on writing some of the same stuff over and over again, or if you're gonna call it multiple times. So yeah, and there can be functions with parameters and without parameters. So in this case, there are no parameters because there's nothing inside the parentheses over here in greet. Oh, but if you wanted to pass in data, you would have some parameters. So if you wanted to, let's say, pass in the name and time, then you would write name and time inside the parameters over here like that. Then this is a print statement. What this does is basically gonna print good, whatever time was passed into the function, then the name that was passed into the function, and then hope you are doing well. So some of you might be wondering what this F is for. So if you remember in the last workshop, we used the plus sign to concatenate the strings. But in this case, the F kind of just already does that. If you are going to have some parameter that you want to enter into the print statement, instead of doing good in quotes, then plus, and then time plus name plus quotes, exclamations, and then hope you're doing well. Instead of that, you can just have it all in one sentence, just how you kind of want it to look like. And this F will just pass in the values, and you don't have to use the string concatenation with a plus sign. So is that clear on the function of F over there in the print statements? Yeah, so it's just like a nicer and convenient way to do string concatenations in print statements, essentially. So let's say I called the read function, right, with the parameters of my name, Kushi, and then the time is morning. So if I was calling greet with Kushi and morning, then we go into the greet function. The name, the first parameter is the name. So wherever you see name inside over here, you see name over here. So the name Kushi will be passed in right here. And then the time is morning. So the time morning will be passed in right over here. So it's gonna be good morning, comma, Kushi, exclamation, hope you're doing well, exclamation. And that's what's gonna be printed to the console. Any questions on how passing in the data works or anything about the print statements? Okay. If let's say if you wanted to set some default parameters, well, what if you didn't want to always give an input, but you just wanted to have like some default thing that just always passes in, right? Then you could just set it the parameter inside the function itself, right? This. So if I wanted to set the default name, then I wanted to set name to the default value of my name, Kushi, and the time to be the default afternoon. I can just do like this, right? You have the function definite greet, then the name parameter, but I'm just setting it to my name, Kushi, and then the time to afternoon. Then it's just always going to be passed in as time is going to be passed in as afternoon, and my name is going to be passed in right here as Kushi. So this is going to always print good afternoon, Kushi. But if I wanted to change it, right, I could just pass in the values, and when I'm calling it, I could just pass in some values and the default will change. So now this time it's gonna print good morning, Nikhil, if I passed in Nikhil as a first parameter and morning as a second parameter. Everyone understand the difference between default and just when you're just calling the function, and then it's just gonna go into the default, and then but if you pass in the parameters, it's just gonna take in whatever you're passing in. If you have any questions, just feel free to raise your hand. Okay, cool. Now we have return statements. So the way we can decide if our function outputs anything like a value is by return statements, right? So let's say you have this function multiply by 3 and you have the parameter num. Num is the number you're gonna pass in, whatever you want to be multiplied by 3. So inside the function where what we're doing is we have a variable called new num, and you're setting that to the parameter value, which is a num times 3. Then you're gonna print done and return the new num. What is new num? New num is whatever was passed in times 3. So outside when you call the function, right? Multiply by 3 and you pass in the value 2. Then what happens is 2 is passing over here. So num is 2. So new num is 2 times 3. So then that means new num is gonna be 6. And then you're gonna print done. And then you're gonna return 6. And since you're putting that function call inside print statement, this means the number 6 is gonna be printed out. If you didn't put print, if you just had multiply by 3 2, it's not gonna print anything to the console. You're just gonna do it, but you're not gonna have anything printed because you didn't have except for done. So any questions on the purpose of return statements or just this function itself? All right, so is everyone clear on functions then? All right, then it's time for you to write your own function that computes an area of a circle. So you can just search up an online Python interpreter, or on Google you can just go and open this link with just program it. You just type in, go on Google, right, and just type in Python online IDE or something. Then you can open the second one right here and just start typing in code that basically does this. You're gonna create a function that computes the area of a circle. The way you can do that is basically by starting off, it's gonna take an input number, right? It's gonna take in the radius and you're gonna return the area. And for those of you who forgot the formula of a circle, it's just pi or squared. So right here, you can set the pi to 3.142 or something, or even just 3.14, whatever you want. And r squared is, you can also write that as r times r for simplicity. And you're gonna, once you complete the function, you're gonna have the user stored into a variable and then call the function, right? So let's say once you have your function and I called stored input equals input, and then input, this is gonna get the user to type in the input in the console. So it's gonna put an input, the user types in. So let's say I typed in the number 5, then your function should return me the area when the radius is 5. So is everyone clear on that? All right, so if you have any questions, just feel free to raise your hand. I'll walk around and answer any questions you have. I think everyone had quite enough time to work on this, so I'll just go over what I had. So basically what I did was use the library math, right? If you looked it up, you're allowed to use the Python documentation, which I talked about in the last workshop. If everyone can like quiet down as well, that would be good, so everyone can hear, so, okay. So what I'm doing is basically importing math from the library Pi. So I have the math library, I'm putting Pi from that library math. So now we're here, finding area, I call the function find area. I'm passing in a parameter R, which will represent the radius. So inside the function, what I'm doing is I'm setting the variable pi to 3.14. You could have also just used the math pi if you imported math and stuff, but I just wanted to keep it simple enough for people to understand. So I'm just manually entering it as 3.142. Then you just have the area formula. So area equals pi times r squared, which is just r times r. Then you're gonna print the area and you're gonna return the area. And over here, I'm gonna get the input from the user. So input radius is the variable I'm setting to get whatever the user enters. So input, and when I'm in the console, it's gonna print enter radius size. So there's that, and then you're gonna call the function find area. And if you remember when I talked about inputs are always strings. So you want to typecast that into an int, and then pass that into the find area function. So if I run this, just okay. So if I run that in the console, as you saw, it's gonna ask enter radius size. So let's say I entered 5. Then it's gonna go into that function. 5 is gonna be in the R, then R times R 5 times 5 times pi. It's gonna give you 78.55. It's gonna print the area, which is printed right here. Area 78.55, and it's just returned, and that's it. Any questions on the function find area? Okay, cool. So we've covered functions. Now we'll move on to the basic data structures that are used in Pythons to test the list, tuples, sets, and dictionaries. So data structures are basically containers that can hold data that you can easily access. So there are different types of data structures, and each of them have their own unique properties or advantages and disadvantages. So for example, over here you have a list. In the list, it's 3, 6, 9, and 12. An easy way to know if it's a list is basically these brackets around it. So, lists are also like known as arrays. If you've heard of arrays, that's basically that. You can index into it. You can they're ordered, and you can also mutate the elements. Mutable means you can change the elements by indexing into it, and you can set it to a different value if you want. Then you have a tuple. So some tuple is 3, 6, 9, 12 and has those elements, but the way you identify that it's a tuple is because you have these parentheses instead of these brackets. So it behaves pretty similar to a list, but the only difference is that it's immutable. So it's still ordered like a list, but you can't change the values. That's what immutable means. Immutable means you can't change anything. It's just whatever you initially set it as. Any questions on that? I will cover a bit more. So, okay. So lists are, as I mentioned, you can mutate them. So that means you can append to it, so you can add elements, or you can also remove elements pretty easily. So for example, you have the list, some list, which is 3, 6, 9, and 12. Then you the same variable, some list dot append. Basically adds whatever number or value you have inside the parentheses. So if I wanted to add 15 to that list, I would just do some list dot append and 15. And then if I print it, then this time it's going to print 3, 6, 9, 12, and 15. 15 gets added at the end. Then if I want to remove an element, then I would just do some list dot remove. And then if I want to remove the element 12 that's already in the list, then I'll just put 12 inside the parentheses. And if I print the list again, then 12 is going to be gone. So now you only have 3, 6, 9, and 15. Anyone want to guess what would happen if you try to remove an element that's not in the list? So like, yeah. Yeah, so like if there's nothing in the list, how are you like gonna remove, right? So that's an error. Okay, now on to sorting. Yes,
You were to try to remove, element that would add to it, would remove both or just one?
right. So if an element was there twice in the list, then what would happen? It would just remove one of them, the first one. And if you want to remove it at a specific index, then there you'd have to like specify the index you want to remove it. Yeah. Okay, so on to sorting. So Python makes sorting really easy actually. So all you have to do is just call the function sort. And so for example, you have the list 4, 2, 3, and 1. Then if you wanted to sort that into a numerical a value, right? If you want to sort it, then you just do list dot sort. And then if you print the list, now it's gonna be sorted. So it's gonna print 1, 2, 3, 4. But if you wanted to sort it in like the reverse, like from greatest to smallest, then you could just do reverse equals true. That's a parameter for the sort function. So it would be list dot sort reverse equals true. That's just gonna reverse the list. So instead of 1, 2, 3, 4, you're gonna have 4, 3, 2, and 1. Any questions on sorting? Okay. So you don't just sort numbers, you can also sort them strings, right? The way it sorts it is basically by the alphabetical order. So if you have the words sun god, king triton, and raccoon, and you call the sort function on that, so words dot sort, and then if you print it out, what do you think will be outputted? Anyone? Yes.
This would be each my end.
Yeah, you just sort it alphabetically. So, and you can also sort other objects like within the list, like floats or characters like chars and also tuples. So onto sets. Sets are also data structures. So the sets are different from lists and tuples because they are unordered. But like the tuples, sets are immutable or unchangeable. So basic, and you can't have duplicate values in sets. So if and sets are always like wrapped in curly braces, as you can see over there. That's how you distinguish them. So if you remember, the list that had the square brackets, the tuples had the parentheses, and sets have these curly braces. So that's how you distinguish all these data structures. And let's say you set data with the values hello and world. And if you were to do print data at index 0, that's going to give you an error. And that's because lists are unordered. So they can be anywhere, right? So if you try to index at 0, it's not going to give you hello because if it was a list, it would give you hello, but since this is unordered, it can also be the order like world and hello. It doesn't know, oh, it's stored at index 0 or something. So that's why you have that error. So similarly, when you do data at index 0 equals goodbye, first of all, it's unordered, right? But if this would be trying to add an element, but you can't do that because sets are unchangeable or immutable. So it's just whatever you originally had it defined as. You can't add things to it anymore. But what is allowed in this, so you can also just set data, you can replace it completely by just having that variable and just setting it to a completely new set. So if you set data equals hello and then 0, that's gonna be your new data. So now data doesn't know hello and world. Now it only knows hello and 0. But then if you wanted to change that again, then you just call data again and then set it to a new set. So if you wanted to have hello, and data will be hello. Any questions on this? Okay. So is which of these lines will throw an error. You can take a look at it and also discuss with those at your table first. If you think you know the answer, just feel free to raise your hand. Anyone want to take a guess on this? Yes.
There's something else.
So we have an answer of only 6. Anyone else? Yeah. So we have an answer of 6 and 8. Those are both correct. So the reason why those two throw an error is because if you remember, structure 2 is defined as a tuple, but you can't, it's immutable, right? So you can't add any element to it. That's why this is gonna throw you an error. So number 6 throws an error because of that. And then separately for 8, you're trying to index into this set, but if you remember, sets are unordered, so you can't go and try to index into it. So those two are the ones that throw in those errors. The others actually work. So the first one is a list. You can treat it as an array, right? So you can actually index into it. So the first one is fine. The second one is fine. Third one, since it's a list, you can append to it. So that third one is also correct. And 2 is just, that's how you define a tuple. So that won't throw you an error. And if you were to print it, you can also index into it because it is ordered like lists. And 7 is, that's how you define sets. So any questions on why these 2 are the only ones that throw an error? Okay, cool. So on to dictionaries. Dictionaries are basically data structures that store data as key value pairs. And they are unordered, but they are changeable. You can change them. And another thing is they don't allow any duplicates. So keys need to be immutable. So type, so like it can be a string or an int. So you can't change the keys. And there are also like a list of built-in functions for the dictionaries, like clear, copy from keys, get items, keys, pop item, set default, update and values. You can look at the descriptions and stuff later as well. So in this example that I have over here, I'm defining a person as a dictionary, right? So the inside you have these keys: first name, age, major, and minors. Those are the keys. So all the things on the left are your keys, and each key is paired to a value, which is the values are on the right. So the key first name is paired with the value Kushi. The key age is paired with the value 19. The key major is paired with computer science. The key minors is paired with the list of bioinformatics. And that's defined as person. And then if you wanted to access or update that data, let's say you wanted to update, you want to print the first name first of all, right? You wanted to access what the first name is of person, then this is how you do it: person, and then you just index into it. But inside you call the key. So the key was first name, so I'm calling the key first name because that's what I want to get. I want to get the value of that key, and I want to print it. So this is going to print the value Kushi. Then over here, if you wanted to like update it, let's say, then you would go into that person, the dictionary. Then this, instead of indexing it by a number or something, you're indexing by whatever key the value you want to change. So let's say you wanted to change the value Kushi for the first key first name to Nikhil, then this is how you do it. You do person at the value, the key first name, and you want to set the value to Nikhil now. He is the other hackhead, by the way. Then next up we have person. If you want to change the value for the key minors, this is how you'd go about it. Person minors equals, now you wanted to change it to cognitive science, let's say the list cognitive science. That's how you would change the value. That's how you're updating the values for specific keys. And then if you wanted to add attributes or something, let's say for person at index 0, you want to add like supply. That's how you go about adding stuff in. And you can also call this function a person dot keys. The key that will basically give you a list of all the keys. So in this case, if you call a do print person dot keys, it's gonna print all the keys. So first name, age, major, and minors. Those are the things that's gonna print out. Any questions on dictionaries?
For the minors, like, where the person minors not that.
Yeah, so one way to go about that is basically you go into that key, right? And then you'd also have to like go inside that list. So you'd have to access like another element. So you have like another pair of like brackets, and then you access like whatever index you want to be at. Good question though. Anyone else or? Okay, cool. Then it's your turn. So now you're gonna write your own list or dictionary. So first of all, create a function that gives you a list of the powers of 2, where the parameter is n. So you have the a function powers of 2, basically, as you would expect, right? Whatever value you pass in, you want to get the power of that, power of 2 for that. So this would be, if you pass in 3, you want to get 1, 2, and 4. What that does is basically you have, if you have 3, right? So you want to go 2, you want to print 2 to the 1, 2 to the 0, then 2 to the 1, and 2 to the 2. Because it's 3, so you're indexing by 0, 1, and 2. Is the function clear to everyone? Okay, I'm gonna assume that yes. You can also raise your hand if you have any questions. Then you're gonna create a function so that's similar. So it's gonna achieve some similar things, but instead of a list, you want it as a dictionary now. So you want to store the keys and the values. So the keys, if you had 3 into the dictionary function, right? Then you're going to store the keys as the indices. So 0, 1, and 2. And for the values of each index, is going to be the power of 2 at that index. So let's write those 2 functions. And if you have any questions, feel free to raise your hand. Okay, I'll just go over what I came up with for the functions and for the list and dictionary. Once this loads. Okay, cool. So also the three ticks that you see are basically a way to do multi-line comment. So you just have three ticks at the beginning and three ticks at the bottom. That's gonna comment out whatever you have in the middle of those three ticks. So now for the solution, so I came up with this. So the powers of 2 for the list, I have defined the function powers of 2 with the parameter n, and you have the list set it to an empty list initially. Then I loop through for the values of n, which is the parameter that you had. Then in the list, I'm appending the 2 to the power of I. I is gonna be the numbers, right? 0, 1, 2, up to n. So 2 to the that power, basically. And powers, if you remember from the last workshop, you have 2 stars. That's the power. If you just had 1 star, it would be multiplication. And then after you add stuff to the list, you're gonna return that list. And then over here, I'm calling the function. So with the parameter 3, and I'm printing that out. And then for the dictionary, I have the powers of 2 dictionary with the parameter n. I have a list or a dictionary, you could have called it, which is calling the powers of 2 the list function that I had above. Now I have a dictionary, which is an empty dictionary. Then I'm looping through for n times, similar to how I did for the list, except this time I'm gonna be doing a dictionary, right? So instead of a list on a pen, the way to add to the dictionaries is add index I. So dictionary I equals the whatever you get from the list, right? And the list is going to give you the values, right? So in this case, for index 0, that's going to be I, right? Then 1 and 2 and 3. Sorry, 0, 1, and 2, since their number is 3. Then the list I is going to give you those values, which is 1, 2, and 4. So that's how you're going to be storing them in. So, and I'm just going to return that dictionary. Over here, I'm calling the dictionary function with the parameter 3 and printing it out. So if I were to run this, oh, okay, line 66. All right. So if I ran this, ignore the bottom part, but just the first 2 things over here. The first 2 things right here. So that the first part was printed from the list, and the second part was printed from the dictionary. So any questions on these 2, the list or the dictionary functions? Okay, I assume not. Then moving on to the last part of our workshop, our classes. So for classes in Python, they basically primitive type. So let's say you have the type 13, then it's going to give you the class in it. Then it just like tells you the type of stuff it is. And so this if it's 13, that's an int, right? So it's gonna say it's type int, basically. Then it's also type int. But if it was a string like hello world, it's gonna tell you that it's basically of type string. And then if you gave typed a list, and you know that's a list because you have the square brackets, that's gonna tell you it's a type of list. And basically what classes does is it allows you to bundle all the data and functionality together. And you can create new types of objects and also make instances of them. So you'll see from examples. So over here, whenever you want to create a class, so in Python, the way you do that is you have a constructor. So in Java, you always have the constructor. So this is how you make the constructor in Python. It's underscored init underscores, and then the self, you can treat the self as basically like the this in the Java, like you know how you have this to point to objects, right? The self is kind of like that essentially. So, and you always have it in all of the functions to refer to that object. And then this is just some parameters, right? So like if, let's say you wanted a class for a dog, then, you know, and this is the constructor. So you wanted the breed and the bark type. So you do self.breed, then it's going to be the breed. And then the bark, self.bark is initialized bark. So the variables breed and bark are each initialized to whatever you passed in the breed or the bark. And also we have this variable speed that's initialized to 5. That's what the constructor does. Then you would create the instances, right? So instances are basically you creating the type of whatever class you had. So if you wanted to create a new dog, right? Let's say you wanted to create Snoopy. Then you have dog, the class dog. That's like the instance of class dog. That's what it's saying. And you pass in the breed and the bark. So beagle and wolf. So that's your type of dog you have for Snoopy. Then for Pluto, it's another dog. So the type of class dog, you want to initialize it to bloodhound and bark as a bark sound. So that's how you create those instances. So any questions on what self does or how to do a constructor or anything? And as you can see, the constructor is indented inside the class name. So you have the class dog and then the colon, just like as if it was a function, but you have the class and then inside is a constructor indented like that over here. And then if you wanted to have functions, you'd also have it indented like that. If you just a reminder that Python is very indent specific. Okay, so no questions, then we can keep going. So we can define more functions, right? In the classes to use or update the properties and stuff. And all of them can be accessed by their instances. And to do that, we always have the self to refer to that object, right? Like in Java, you use this dot to update some things, right? So objects and stuff, instead of this itself. So let's say you have the class dog, right? In this case, you have functions to set and get the breed. So you know how you have the setters and getters in Java for your functions and stuff in your classes. In Python, so you have the set function, right? So you always have self inside. So in Python and in Java, you can just call this, but in Python, in the function, you always want to have the first parameter as self. And so, and then you have the name, right? So you wanna set the dog name, set the breed with the name. So self.breed. So now the breed is whatever you pass in the name as. Then your get function. Similarly, this is just self like this dot breed, right? So return the breed of it. And then example of a function using these properties would be like speed, right? So you pass in yourself. Speed doesn't have a parameters that when you were calling it, as you can see over here at the bottom, you just have it speak. You wouldn't write anything inside of it. But what self does is just gonna print a plus the breed, the type of breed it is, and says and the bark. So how do you call it, right? So Snoopy, first of all, you set the dog, right, by the class, right? So Snoopy is dog, with whose breed is beagle, and the bark sound is woof. Then you want to set the breed to a golden retriever, let's say. So Snoopy dot set golden retriever. So now instead of beagle, it's a golden retriever. And then Snoopy dot speed. So that's just gonna output A, and then the breed, which would be golden retriever now. S says, and then the bark sound, which is still be woof. So is that clear? Okay. So more examples. Also, obviously you can use sort again. So when we called the words dot sort earlier, we were calling the method from the class list itself. So you can just, there are a bunch of classes in the Java documentation. You can just look them up, as I mentioned before. So now the last coding exercise for today, you're gonna create a class, basically combining all the things you've learned today, like sorting and classes and stuff. So this time it's gonna create a class ordered list. This is your constructor. That you need the format basically right here, you have underscores init underscore self, and you need the self as a first parameter to have the object reference. And you can just use this small template, the starter code over here. And basically what you want is to create a class ordered list that contains a list that's always going to be sorted in ascending order. So if you were to pass in the list 316 and you printed it out, like once it's ordered, if you print it out, then it should print 1, 3, and 6, just sorted from smallest to greatest. And this will be the last exercise for today, so.
I mean, you gotta remember how much. Okay, but if that is about the law, it is yeah, it doesn't matter. I mean. Like, they're not. That's really nice. That's very much. You kind of went through the back and now we're going. But you want to do it more. Yeah. People kind but yeah. Thank you. Oh.
Okay, I think that should be enough time for most of you. So let's just go over what I had. So for this, for the ordered list class, right? So you have the class name ordered list. And as I mentioned before, you want to indent all of your functions and everything inside of the class. So now you have the constructor right here, which is gonna just basically just gonna initialize the list, whatever the list is. Then you also just wanted to sort that list that you have initialized to. Then over here to add, you're just gonna call self the list to get that list. And in that list, you wanna add elements, right? So that means you wanna use the function append, if you remember that from the side about list. Then so you do self.list.append, and you wanna append that element that is being passed into for the add function. And then you wanna sort that list, so self.list.sort. This is basically like saying get that list. So self.list is like equivalent to like this dot list in Java or something. So you get that list and you sort it. Then if you wanted to remove an element, you do self.list.remove, and then that remove that element. You use the remove function. And if you wanted to get something, you just return that list, self.list. And if you, so basically that's your class right there. And then in order to call something, you create an ordered list. You have, I just named it ordered. So you have the class ordered list name, right? So it knows it's gonna be a type of ordered list. I've created a list with the numbers 3, 1, and 6. Then I'm just printing it out to see what I initially have as my list. So it's over here, as I can see in line 56, what was printed is 1, 3, and 6. Then if I wanted to, let's say, get an element and add an element 4 to that list, I would just do order.add and the element 4. So it's gonna go in here for add element 4, elements gonna be 4. So that list, which is 3, 1, and 6. You're gonna add the element 4, and then you're gonna sort it. So now you have 1, 3, 4, and 6 after you sort it. So when you print it out over here in line 58, well, you're gonna all line to 3 now. You're gonna get 1, 3, 4, and 6. And then over here in line 65, which is written at 60 because of spacing I had. So over here, after you remove the element 3, you're gonna go in here, right? For the remove function, you're gonna remove the element 3. So in that list, now you have 1, 6, and 4 because you added that 4. 4 is still in that list. So you just remove that 3. So now you have 1, 4, and 6. And that's what's printed. So any questions on the class ordered list? No? Okay, cool. So then that's pretty much it, but I know we're kind of out of time, but I just wanted to get some feedback and just like go around and just raise your hand and just tell me what you learned from this Python series so far, like the last workshop if you came or if you watched the recording, and or from today, whatever you think. Yes. Nice. You want to share anything? Okay. Yeah, nice. Cool. Would you like to share anything?
I don't know about this.
Anyone else want to share? Okay, I don't know if you want to stay with us. Alright, I'm not really familiar with some things like classes, tuples, just like a basic syntax of Python. That was the whole purpose of this workshop, just so everyone's familiar with it, because Python is actually very popular now. It's used in industry, like people have interned at companies and they've had to use Python in their internships. And it's also heavily used in research, especially for computer vision
about machine learning and also AI. So if you see those people back there, they are working on 152A. That is a computer vision class. That is using Python. All the homework is done in Python. So yeah. Hopefully this series helped you learn something about Python because very helpful. And then these are just additional resources just to, if you're not keep learning more Python and then like more about it, like at a more advanced level, these are just some starting resources. Obviously you can just Google and find a bunch of resources. And if you still have any questions, you can always message me on Discord as well. And basically the last workshop for Hack.py is gonna be next Thursday in the same room right here from 5 to 7, same time. And this one is gonna be a panel. So in the panel, we have a PhD student who does research in computer vision, machine learning. And he used Python, and he's gonna talk about why he used Python, the benefits of it, and just about his research as well. And we also have some master students. One of them is right there, Eric, if you wanna raise, or if they have. Yes, he will be on the panel. He has done some research and also did an internship at Apple. So he's gonna talk about how he used Python at the internship and stuff. We also have a bunch of other people, undergrad students who did internships at various different companies like Meta and also like small ones. So they're gonna talk about how they use Python, how it was applied for their projects, and yeah, just their research and internships themselves. So I hope we all come out to that one as well. And that's it though. So thank you all for coming. If you have any questions, you can always ask me or